Okay, let's start with this topic. But previously, we were looking at these things. So this is something understand the data through statistics maybe, and then this normalization L1, L2. Then we saw the binarization, standardization, and now it is data labeling or data encoding. So from its name, this data labeling is a little bit confusing, but from its name, data encoding, the things are quite clear. So if we will look for a definition for this data encoding, or if we will look for what we normally do in this data encoding, then normally in data set, sometime if you have some nominal values means nouns, okay? Or here we are saying it if we have categorical columns, which means those nominal values. Then sometime we want to convert those categorical columns or nominal values into numerical values. Why? Because there are some machine learning models and those models takes only numerical data. So that's why we want sometimes to convert to encode our uh, categories. Maybe it can be the name of the columns, okay, or it can be the values of the columns. So if those values are nominal or something like that, then we normally go for encoding them into numerical values. So in scikit, sorry for that. In scikit uh, learn library, we have some function available which is label encoder. So we can use this function to encode our data into numerical values. How we can do that? Let's see that this source code. And here, these are just importing some libraries and the classes. So import numpy as np. Okay, so we are using numpy. And then we are using sklearn and we are importing pre-processing class of this library. And then after that, here we are making basically an array or list, you can say. So here, this is a list and some nominal values are there. Some, or you can say some categories are there, red. So all these are strings, huh? Red, black, red, green, black, yellow, white. So we will use this as input categories, as input labels, and this list, we are giving a name to this list, input labels. Okay, so now this is the list with some noun values, huh? And now we will use the label encoder that we talked here. We will use the label encoder now from this pre-processing class. From pre-processing, we are using label encoder. So this line is just setting the label encoder or configuring the label encoder for your purpose. And here we have the object for that through which we can use it further. So here we have the encoder, we can say, after this line. So now label encoder is set and we can use it through this variable. Now after that, what we are doing, encoder.fit. Previously, we were using this fit function again and again, fit transform, fit transform, fit transform in the previous source code. So, but here we have encoder.fit and we are fitting our these labels, which are the strings. We are passing this into it. What will happen when we will pass this into this encoder? And what this is fitting for us, this is basically assigning numerical values, or it is converting these string values into this statement. It is converting these string values or categories into numeric values. This would be one. Sorry, it would be 0 and then 1, and then it will assign 2 here. Sorry. So it will assign the values I can clear this all drawing. So it will assign the values here alphabetically. Okay. So then it will see first this encoder will see first what is the alphabetic order. So black B, some word which is starting from black is the first word, huh? Because there is no any word with the A. So it will assign a 0 to black. Okay. And then it will search the next word in alphabetic order. And then it can be after B, it can be green, huh? Maybe, huh? So it will assign then 1 to it. And then after the green, it will search the next alphabetic order, then maybe this red, and it will assign 2 to this red at all positions. Similarly, then it will search for next, and this will be the white, I think, and then we will have 3 numeric value for this, and similarly 4 for yellow. So this statement will assign these numeric values to all these nominals by looking at the alphabetic order. Okay, then what will happen next? Now, so now you will see the effect. Here we are making another list like this input labels. We are making another list and we are calling it test labels, and we are giving green, red, and black to this list. Okay, these are string values again. And then what? Encoded are transformed. So we are using the same encoder, which is the label encoder. So encoded are transformed. And here we are transforming. We are not fitting or anything. We are transforming. So we are changing the string to numeric values, which is already we already have run our label encoder one time. So all the values are set. If you don't have any new value, then all the values are set. So here encoded are transformed, and we are passing this test label again as a parameter to it. For what purpose? For transformation. For transformation towards numeric values. And then this statement will convert them into encoded values. It will convert them into encoded values. So then green has what value? So from this previous knowledge, green has 1. And then red has what value? Red has 2. And black has what value? Black has 0. So then 1 to 0 will be stored here in this encoded values. Because everything, by looking at this encoded data already, it will transform this input, which is the nouns. It will transform them into this 1 to 0 that will be stored here in this variable encoded values. And then what? Then we have a print statement, and here we are printing print labels, test labels. Test label is this one. It means green, red, and black will be printed by this statement. And print encoded values and list encoded values. Encoded values is this one, which is numeric values 1 to 0. And this is so we are making a list of that, and then we are displaying. So these two statements will print what you can see here. It will first print red, green, black, which was given, and then it will print 1 to 0, encoded values, numeric values. Okay, after that, so now we have this, now we are testing in reverse order. So now we have encoded values, and we are giving these values as a list 3041. So this is a list of values which we are giving to this variable encoded values. So this is a numeric list. And then we are using the encoder again, the same encoder. And then inverse transform. This method is available. Okay. So inverse transform. So transform, but in opposite direction. So, and then we are giving the encoded values, which are this numeric values. And it will do what? It will transform, but it will transform into categories, into nominals. Huh? And those nominals will come here in the decoded list, which we are printing here. First, we are printing encoded values, which are numeric values, and then decoded values, which are the names, which you are seeing here. These two print statements are printing this. First encoded values 3041, and then their nominal values, inverse transform. So this is called data labeling or data encoding that we can use because some of the machine learning models, especially probabilistic ones, which are taking vectors, okay? The machine learning models which are taking vectors, and vector is some numeric form, feature. So then you have to convert your nominal values, if there are in the data set, you have to convert them into numbers, and this is how you can convert them. Okay, moving next. So now we are moving toward the data features selection. This previous part was the preparation of data set. Okay, and then now we are moving towards the data feature selection. Feature selection shortly. So what is feature selection? Let's see the definition first. So we know that feature, attribute, column name are headings in the data set. And what are the other names? So these are the same thing, okay? And these are the same thing. So if we have our data set, sometime we don't know, there are too many features there and we don't need them. So then what? So then there is a option. There is an option that we can include and exclude features from the data set. But we will exclude only those features which are not important to us. And we will include only those features which are important to us for our model. So that is what written here. So including or excluding important features without changing them. We will not modify them. We will just throw them or we will take them. Okay, that is what it means. So that is called feature selection. And what are the benefits? Okay, that is very much general. So it will reduce the overfitting. We already know the definition of overfitting and underfitting from our first CLA. So it will increase the accuracy. So it will increase the accuracy of our model. It will reduce the training time. If you will have less number of features, then automatically training time will be reduced, because you have removed all the features, most of the features you removed. And it will reduce the noise from your data set. Noise is different from sparse data. Sparse data means you in your data set you have zero values. Previously we discussed. And noise is something not zero values, erroneous values. Okay, the values which are not the true picture of the data. Okay, due to some reason, maybe some assembly language symbols are displayed there or something like that. So the values are there, but not correct values. So that will be called noisy data. So, but when you will remove them, if it is existing in some feature, and if you will remove them, it will definitely reducing or cutting down the noise from your data set. And it is also reducing the size of our input data. Okay, this is general sentences. Everybody can understand. Now we will go through one by one the techniques that are available for feature selection. Let's see that. First one is univariate selection. Its name is saying that uni means one, variate normally means from the variable. It is derivation of variable. So univariate selection. So here you have to select the features with respect to your target variable. Target variable means the output class, okay? The class that you want as an output from your model, that class, I can call it a variable, I can call it a category or whatever, and that is my target. So then what? So here in univariate selection, we will use this technique to select only those features from the data set which have a strong relationship with our output class, with our target class. Understood? So that's we will use this technique for that. And in this technique, we will give some value to the k, and if we will give some value to the k, what will happen? It will, if we will give 5 value to k, then it will select 5 best attributes or columns, or columns from your which are related to your target value. It will select from the data set and it will ignore all others. It will select the 5 best when you will give 5 value to k. Anyhow, let's see this code, and then you have the understanding of it. For this, we are using pandas, and we are using the numpy library. And from the sklearn, we are using feature selection class. From that, we are importing select k best. So this is the class which we are importing here, select k best, and this will select those features. We will give value. And then we are using, from the same library, we are using a test which is called chi-square. There are different statistical tests available, chi-square, kappa, alpha, something like that. But here we are using chi-square. And here in this statement, pd.read, so here we are just reading the database, which is train.csv. Sorry, I didn't explain that what example we are going to perform. We are going to perform an example about mobile price classification. The data set for this is available here on this link. It is also available on the Blackboard. You can download from the folder of the data set directly. So mobile price classification, what it means? It means that you will have a specification of different mobile phones. What is the capacity of the RAM? What is cache? How graphic camera? So you have all these specification, and then based on this data, you are predicting the price of the mobile phone. Okay, this is now this program. So your target class, your predicted class is mobile price, price of the mobile. And here we are not predicting price like $100 or $200 or $500. No, maybe we will have a one range. We are calling it, okay, one category is one. We are saying, okay, mobile prices has 3 categories, and we are labeling it 0, 1, 2, and 3. 0 can be mean from $100 to $200, category 2 means from 200 to maybe 400, and similarly category 3 means from 400 to 6 or something like that. But we, in the mobile price, we have these categories 0, 1, 2, and 3. If I will show you the data, okay, so this is the mobile, and if you will go into this data set, come on. Now the system is old, actually, 10 years old. So now this is the data set, and you can see these different columns: battery power, blue, clock speed, dual SIM, something like that. You can see these different columns, and the last column is price range, which is the mobile price. And here you can see 1203, 1203, 1203, all over this column. You don't have anything else. You don't have $100 or 100 rupees, Pakistani or Indian. You don't have anything. So, but here you have the columns. So we want, this class is given with respect to this data. This class is given, but this is not, this data you can use for the training. When your model will be trained, then you will give your own specifications. Okay, and then based on this data, your model will predict the class from here. That you can call it, okay, the new estimated class or predicted class. So anyhow, so now you have seen the data. Now we are going back to the source code, and here we are reading that data, which is the train.csv. Okay, after that, so now your data is in this variable. Okay, here in this example, what we are doing, data.iloc, and then this is a kind of a list. But here, when you have these columns, column here and column here, when you don't have any value before the first column, what it means? It means start from 0. Okay, it means start from 0. So data dot iloc is a built-in function. So it will read the data. Okay, it will read the data from there. From where? From zeroth position. From zeroth position in the data set. Up to what? Then we have this comma. When you have the comma, then it is like a two-dimensional array. Okay, rows first, columns after. So starting from zero, so start from the row zero and go what? And after the comma, whatever you have, 0 to 20, it means those columns. So you will read the column, you will start reading the column from 0, 1, 2, 3, 4, 5, and you will not read the last column, which is 20. And in this data set, now what will happen? In this data set, you have 21 columns. Okay, 21 columns. So if I will start from 0, then I can say 20 columns. So but the last, this column has the number. If you will start from 0, then this column is the 20th column. Okay, and now you will understand that statement from 0, it will start from 0 and it will read what? It will read all the data except the last column, including column headings. So now where is the data? So it will do what? It will start from here. This is the 0th column, huh? And it will go like that. It will leave this last column and it will read all the values, huh, up to the end. That statement will do this. Okay, it will read all the values. So but I have written that thing here. I have given that description or explanation here, and it will read all the values and it will put all those values here in this x variable. And then after that, data dot iloc, again it is similar. Colon, you don't have anything before. When you don't have, it will start again with 0. And here here you have -1. Here you have -1. So what it means? It means now start from the end. Okay, and then start from the 0th row. Okay, starting is 0th row, but when you have -1 here, it means start reading from the end. So then what it will do? It will read all the values of the last column only. So it will do what? It will go into this last column due to that -1, huh? And then it will start from 0, and then it will it will read all these values, okay, of this column only. Okay, and then it will keep all the values here in this y. Okay, now we have something in x and y, and then in the next we are using this select k best. So we are using that method, select k best, and we are saying we want to calculate the score using this chi-square test which we mentioned here. Okay, that is some statistical test. You can read about this by yourself. So we are giving this value. You can change the value here to kappa, to maybe alpha, something like that. So now select k best, and we will want to calculate the score. And what is the test available to calculate the score? Chi-square. And how many features we want to select? We are giving the value 10 to this k, because I explained it to you that when you will give some value to this k, that is the place here. So now this select k best method, you can say now this technique is configured. It will not do anything. It is configured with the 10 features, that it will select 10 features and it will calculate the score by using the test score. It is not calculating it now. No, when we will use it, then it will calculate. But here we have set. Yeah, we are setting this select k best like we are doing in the previous programs. And here we have that every setting is here in this variable best features. And then here best feature dot fit. And now we are fitting this select k best technique over the data, the x and the y. X also has the data, y also has the data. And we are fitting it, and this is the variable or the object through which now we can access it further. Okay, moving next. And here This PD is maybe the pandas, huh? PV is the handle for the pandas, and NP is the handle for the numpy, huh? So PD dot data frame, and here we are passing something. The fit, we already know what is fit. Now your fit is this, huh? Your fit is this, your object. And now you're passing this fit, and you are saying that calculate the scores. Scores. Maybe it is a method available here, huh? So now, what will happen here? It will calculate the scores and it will store the scores here. Okay. It will calculate the scores and it will store the scores here in this variable. And then we have pd.data frame and then x dat column. Okay, x has almost the whole data except the last column. And then x dot column, what this is doing. So this x dot column will do what? It will. So we are storing the column names. Okay, column names, headings only. So in this variable df columns. So now, so here we have the headings, and what is the score of those headings? We have here in this df score. Okay, now let's see what we are doing in the next. These two statements are just for our output. Okay, for our output, we want to display something in a good way. Okay, so here we are doing pd dot concatenate. PD is, again, we are using the pandas library, and concat is the method available there to concat different things. What we are concatenating, we have a list. The first list is df columns, the same, this one. So it will take the call. So this list has first value columns, and then second value it has scores. So you can understand that you will have one here in one column, you have the column names, huh? If we will display something, and on the other side you have the scores in front of it. Okay, so we are making a list and we are saying x is equal to 1, which means vertical direction. Okay, so we are concatenating this as a form of list, like columns first and then their scores, and we are storing it in this feature scores. Now in the next, feature scores, which is that same thing, and then we are saying that, okay, we will display the values like that, but we don't have the headings here. So then what? Features.score.columns. Here we are saying, if this is the data, this is another column with values, but we don't have these headings above it. So now here we are playing with those headings, that feature scores.columns, and we want these two things, specs and score, as the column of these two, as the column heading of these two columns, huh? So which is a kind of, again, a list. This is also a list of two items. This is also a list of two items. The same thing. So pattern is same, format is same. So now what will happen? Now here in the next statement, we are printing what? Feature score. After update, we are just printing feature score. What will happen? What will print out? Let's see. This will print out. So here you can see this is one column with all column names, huh? Column names of the data set. And this is the score for each column here. And this is that heading, specs and score, that you have set at the end. And this 0, 1, 2, 3 is by default, okay? By default, by the output, okay, by the terminal. So this is what displaying due to this statement. And then next, here we are using the print statement again, and we are saying, okay, this will display all the columns, huh? But here we are doing our thing, that feature score, and select only n largest. N largest means we will give the value, huh? And we are giving the value 10. Show only 10 largest. The score is there. From that score, only show the 10 largest scores. And here's we are saying feature scores that n largest give us only 10 with respect to score, okay, with respect to score. So then what? It will print only 10 columns with the highest score, huh? With the highest score. And here you can say their serial number is also changed if this is the serial number. Because randomly now it is giving us in a sorted order, something like that, from highest to lowest, according to the score. And now through this univariate selection, you have selected something, the features, only with the highest score. And this score has what meaning? This score is giving you the meaning that these are the columns which are more contributing to your target class, mobile price. Huh? This is the meaning. You didn't have to think, okay? You don't only have to use that level, select K best, huh? And it is calculating for you. It is calculating the strongest relationship, and then it is giving all the things to you, and you are displaying only the last 10. Clear? I have the source program, for example, but I don't, but it's easy. You can run it by yourself. If you will go into this folder, and this is what univar, this univar means univariate. You can open it. And then you can run this program. So here, Python, the name of this is univar, I think, .py, enter. And here you are seeing all. So all the columns here, according to this code, because this code is a little different, huh? I have not used the last statements there. So here it is mentioned 10 and score, or okay. Then, okay, what is the output? So you can see specs and score, the heading. And after this, you have only 10, huh? Before that, the full, but here you have the only 10. Okay. You can check all this source code there by yourself automatically. Okay, now moving next. Recursive feature elimination. Shortly, we can call it RFE, recursive feature elimination. So there is a library available, RFE, in the scikit-learn. There is a class available in this scikit-learn library. So what this recursive feature elimination will do? So it will rank all the features like before, huh? Like before you saw, according to the score, it ranked. But it will not give you any kind of score, but it will rank according to its own mechanism. And this technique you can use only for small data set, not for large. Okay, it is particularly mentioned for small data set. For example, here we have small data sets. We have all small data set in our for our checking in this course. So it will rank all the features. Features means columns, huh? And then when it will rank, then you can eliminate further. But it is mentioned there, then you can eliminate the lower ones and you can take only the high ones. So it will perform the same thing like the previous one in a different way. So now we are going to perform this RFE on the same PIMA Indian diabetes data set. So that is the same statement for reading the data set. And here SK learn feature, we are importing RFE because we want to use it. And then we are importing logistic regression. This is a classification model, okay? This is a supervised learning model, but leave it for a moment, okay? Here we are using it, but we will not go into this detail because the next CLO is about different models which are available in supervised learning, and we will start with the logistic regression. Okay, we will start with the logistic regression. I will not start with the linear regression because that is easy. Everybody understand. So I will start with the logistic regression because it is the base for the neural network. And nowadays, neural network is popular all over. You know the name of the deep learning, and deep learning is what? It is all about neural network. So anyhow, so we are going to use the logistic regression here, but we will not go into detail how that thing is performing here in this program. We will go into the detail of this logistic regression in the next CLO. We will start with it. Anyhow, here we are loading that database, and then we are generating the headers because headers are not available in this database by default. So we are giving our own headers, and then we are reading the database and storing it here in data frame. And here data frame.values, we are taking the values of that data and storing it in array. I'm not explaining it because we already explained it in the previous algorithms. So what is here now? We have this array. So now what we are doing here, so array colon. So we are again starting from 0, and then we have the comma, which means this means the number of columns. So from the data set we have 9 columns. Okay, in that data set we have 9 columns, and it means read from the 0 and read all the values including the column headings, but leave this last one. The last column is not the part. Okay, this is what the same understanding. So I have written it, and then y means, okay, read from the 0 but only one column, that is the last one. Number 8 is written there. It is not from 0 to 8. The number 8 is written there. So you can write -1, or you can write the number of the last column. So it will read again only the last column from 0, all the values of the last column. Okay, it is written here. What is the meaning of that? It is written here. And then here, this is RFE that we are going to use. But okay, let's see that we are also using logistic regression here, because it is also doing something for the RFE. RFE normally needs some kind of a model. RFE needs a model, some supervised model or some unsupervised, but it needs some model. So that's why we are using this logistic regression here. Here we are using logistic regression, which is available in this scikit-learn library as it is. So here you can say we are using a method. We are using a function. And here the first parameter of this function is, okay, solver reserved word and LBFGS. This LBFGS is a algorithm. Its name is lengthy name. It is not. If I show you on the internet, then you can see what is the name of this LBFGS. So this is an algorithm for optimizing the values. We will use this for optimizing the values. So if I write what was LBFGS? So this is limited memory, Broyden, Fletcher, Goldfarb, Shano. Okay, this is the name of the algorithm. Normally we use for optimization in machine learning, for optimization of values. Okay, so we are not going into that much detail. So this is an algorithm, nothing else. And we will run this logistic regression or this algorithm 500 times, maximum iteration 500 times. Okay, and here we are setting, this model, and we are storing it in this variable. So this model is now set, that logistic regression is now set. We will use this logistic regression in the RFE. This is now our actual RFE, recursive feature elimination technique. And the first parameter of this is the model. And what is that model now? We are using logistic regression. And then we are saying, select what number of features to select. This is a reserved word, and we are giving value 3 to it. And we are saying only from those 9 columns, select only 3 columns. From those 9 features, select only 3 features. This is what we are saying to it. And okay, okay, so this RFE is now set, and this is the handle for that. And then RFE.fit, and we are passing our data, which is X and Y, into it. Now it will fit, and we have this handle, our object. Here we are using number of features, %D, okay, fit dot number of features. What are the, when you fit this, or when you fitted this RFE over this data, then it has done all the thing according to that RFE technique. And then what are the number of features available here in this fit? It will give you. We already have given it 3. Select 3. So it will display you the 3 number of features with this print command. And then print selected features %s fit dot support. It will display you this thing, which is all the columns with the status that which column is selected and which is not. In other words, which feature is selected, which is not. So here you can see the first feature is selected. The first column from the data set is selected. It is true. All other are false, false, false. And then this one is selected, and then this one is selected. All others are not selected. Okay, this is due to this support. And then print feature ranking. And now we are displaying the ranking of it, ranking of each column. So the first column has the ranking 1, and then this second, okay, it has again the 2, then 3rd, then 5, then 6, then 1, 1, then 4. What it means? It means that this column and these 2 columns has the first ranking, highest, highest. And then after that, this column, and then this column, and then this column. But we have mentioned here that we are going to select 3 features only, and this RFE is now selecting those 3 features, first one, second, and third. So this RFE is selecting these features. And if you will see the names of these columns according to the order in the data set, if you will see them, their names would be pregnancy, mass, and paddy something in the data set, in the PyMindian. So now this technique is selecting the features like this. Moving next. Principal component analysis. It is red, okay? Red means students have to do it by themselves. But only for the CO, I am going through this, only for the beginning. Because it is also an important technique, it will come in the next. So this principal component analysis is also a technique to select the features, to select or reduce, include or exclude. You can use those words again and again. So PCA is a technique through which we can decrease the number of features, so we can reduce the number of features. And we will, by selecting dimensions of the feature, dimension, size of the feature, the number of values, and then which will have, and we will decrease the number of features which have most the variance. Variance means vary from each other, different from each other. One feature is how much different, how their values are scattered. You can say there is a one column, and the values of that column may be scattered in the whole figure. If you plot it visually, one value here, one other value. So if you plot something, so the data points of some feature, you will have some value here, other value maybe here, other value here, and then most of the values here, and you will see some values scattered. So if you have this situation, this is called variance. This is called variance. So this variance can be the variance among the columns, or we can see among the data points of single feature. So then this principal component analysis, it will reduce the unwanted features from your data set based on this technique of variance, which means scattered values. Huh? Now we have an example. We will use the PCA to extract the features. For this, we are using the sklearn, and from the sklearn, we are using the classes decomposition. Decomposition. This is the class that we will use, okay, mainly. And then in this sklearn, some data sets are available. So we are using the available data set directly from here. We are not giving paths of the data set. And here, dataset dot load, and the name of the data set is breast cancer. We are loading that data set directly from this sklearn, which is available there by default. And here we have the data set, and then data set, their data, what data in it, we are storing it in this X with all values and columns and with all stuff, okay? We are storing it in this X, and then we are printing X dot shape. Shape is a word which will display the number of rows and columns, okay? So it will display the number of rows and columns, and here print X, which will display the number of, print X means it will display the data, because in the X we have all the data. In X we have all the data. We are storing all the data here in the X. So if you will see the output, you will see first this is shape, and here this is all the data with these numbers, and so on is there, okay, and so on. So it's a huge data set, okay, and so you can see their values. So these are real values, huh? Okay, so this is the output up to this point, and then okay, coming back here, we are just using standard scalar. You already used this standard scalar in the previous programs, okay? Where we studied what is standardization. Okay, take the mean zeros and standard deviation 1, then take one value from the cell, subtract the mean from it, and whatever the result, divide it with the standard deviation. This thing we studied in the previous lecture, huh? So that was the standard scalar. So we are using that standard scalar through this statement, and this is the handle for that. And here std dot this is the handle dot fit transform, and we are passing our data into it, which is the X, and it will transform the values. It will rescale the values, you can say, okay? It will standardize the values, and it after standardize, it will keep or store all those values here in this handle. And then again, we are printing, we are using the same handle, and the shape, it will display rows and columns, and then it will display the data. Here you will see. So it is again displaying the shape, and then it is displaying the data again with updated values. Now, previously it was 1.7 something now, but it is now 1097. And this is something, so values are changed. Values are changed. So you can say values are rescaled. Why we did this? Because it is scattered, huh? So it is scattered. We want to make them close to each other. This is what we studied in that previous technique. We want to make all data points close to each other. And then we will apply the PCA here, okay? And then we are applying the PCA through that decomposition. We are taking this PCA, and we are saying select only 4 features. Number of components mean features, huh? But this is the reserved word. You have to use it as it is, huh? So PCA number of components is equal to 4. So this is a huge list of features. This is one feature. This is second feature, mean column, third, fourth, and so on is also available. Maybe you have 25 or I don't know, because I have not seen the data set, okay? So, but you have many columns there. And here we are saying, give us only 4 from that and ignore others, okay? And then what? Here, the PCA is now set. PCA is now set, and here we are transforming the data. And XSTD is the data with rescaled. This is rescaled data or standardized data in the previous step. So we are passing into it, and then it will be transformed. It will throw all the features except 4, and it will store those 4 features here. And when you will print xdd.shape, it will display the rows and columns. And here you can say number of rows is 569 and column is 4. 4 columns. It has 5, 6, 9 rows in it. So this is due to that shape. And then print the data xtd dot the same handle. So now it is displaying, and it is displaying now. So it is displaying only the highest related columns, and it is throwing all others. And it is throwing all others. And you don't have any and so on here, okay? And so on is only available row wise, not column wise. So these are only the 4 columns you have now. So this program is also available because you have the green color here. So you can check it by yourself from the folder. And now the feature importance. I will stop at 6:30, okay, for the play. Okay, I will stop. Feature, or maybe after this, yes, this is good for us. Now CLO is going to end, huh? CLO2 is going to end. So feature importance. After this topic, we will stop for the break. Feature importance. Now this is another name for this technique, feature importance. From its name, you can understand that we will select only important features, huh? From its name, okay? So we will select only important features. But how? By using some supervised classifier. In the previous recursive feature elimination, we also use some logistic regression, huh? And here we are going to use another classifier for that. You don't have to go into the details of this classifier because this is not our point. Here our point is feature selection. Our topic is feature selection. Something is available in the libraries of the Python, so we have to use that for this purpose. So now example is implement extra tree classifier from the scikit-learn. We will implement this for selecting important features. Okay, from the sklearn and in ensemble of sklearn, we have this extra trees classifier available there. We are importing it into our code. And then we are reading the PyMindian, we are generating the headers, we are reading the database, we are putting the values in the array. And then we are reading all the values except the last column in X. And then we are reading only the last column with the values here in Y. And then what? Here we are setting the extra trees classifier, which is that one we imported here. Extra trees classifier, we are calling it, and that will be set, and we will access that extra trees classifier through this handle. So it is a variable for us. And then we are using the same variable here, model.fit. Now we are fitting our data into it. Okay, now our data is fit in it or fitted in it. Then here we are printing. Then here we are printing. How we can print? Model.feature underscore importance. So display the features according to their importance. Okay, this method will do what? It will display the features. So print method will display the features according to their importance. That importance will have some real value. Okay, again, huh? So what will happen next? And here is the output. It is displaying your feature. This is feature number 1, 2, 3, heading number 4, 5, 6, 7, or 8, whatever. And if you will see, this feature has the highest value. Okay. So here it is displaying according to their real. It is also a ranking, huh? So this feature has the highest value. So this is important for me, huh? And then after that, which one has the highest value? Maybe this one. This has the second highest importance, you can say, or priority. And then this has the third highest importance or priority. And then if you want to select only 3, okay, take these and ignore the others, huh? But this is what these numbers are, has the meaning. These number has what meaning? This number has the ranking of the features importance wise, okay? And then now CLO2 is finished, and inshallah I will upload the practical assignment number 1 now on the blackboard, and then you have to submit the answer also on the blackboard. Okay, what you have to do when you will solve that, you have to upload the source code also, and then you have to make a word file or PDF file, whatever you want to do, and then in that file you will copy the source code again, and you will also copy the output of that source code in that file. So you will upload two files. One is source code separately that I will check, and the other, this file is only for marking. Okay, for marking, I will mark on this file. Okay, so I am